To solve this equation, we need to first identify the system and the surroundings. The system is the object, the surrounding is outer space. Before we solve this problem, we need to find the displacement, which is the final location minus the initial location. And we get this as the change in displacement. We are going to use this equation, final energy equals initial energy plus the work. We could rewrite this as kinetic energy, the final kinetic energy plus the mass times the constant of light squared equals kinetic energy, the initial kinetic energy plus the mass times the constant of light squared plus the net force times the displacement. And we are left with kinetic energy final equals the initial kinetic energy plus the constant net force times the displacement. We can rewrite this as the final kinetic energy equals 1/2 times the mass times velocity squared plus the constant net force times the displacement. We plug in all the variables from the problem into this equation and we get a final kinetic energy of 5,780 joules. And now we can finally solve for the final speed. To solve for the final speed, we are going to use this equation of the kinetic energy equals 1/2 of the mass times velocity squared. We plug in the value for the kinetic energy we found in the last step, and we rearrange to solve for the final velocity. The final velocity is that after doing all that, the final velocity is found to be 9.81 meters per second.